Hello, the objective of this video is to learn how to perform computations using scientific notation. This is part 2 of the video. The previous one went into multiplying and dividing using scientific notation. This one's going to go into adding and subtracting, which, believe it or not, the more complicated of the processes is the adding and subtracting. Multiplying and dividing are actually easier to do than adding and subtracting. We're going to see how to do the adding and subtracting now. To add and subtract scientific notation, you must have the same exponents on the tens. If you don't have the same exponents of the tens, you cannot add or subtract them. That doesn't mean that there's nothing you can do about it. You just need to be able to, you just have to adjust the numbers so that they have the same exponents. So in order to do the adding or subtracting, you must convert them to both have, convert whatever number of scientific numbers you have to have the same exponent on the number of tens. So here, let's talk about just general adding. If I'm adding this number and this number together, the first thing I would do is I'd line them up like this. You remember how you did that back in first grade? You lined up the numbers where the ones lined up, the tens values lined up, hundreds, so on like that. And when you add it together, you had to add the like place values together. 2 plus 5 gave you 7, 3 plus 7 gave you 10, then you got to carry the 1, you get the 6, you get 4,607. You would not add 75 to the 45 there. That is just wrong. So if you're given a problem like this with scientific notation, you don't want to be adding the 3 and the 2.6 together directly, because that's like doing this. You need to make sure you have the same exponents on the tens, otherwise you are not doing the operation correctly. And there is a way to adjust these. So the steps. Step 1, choose which exponent you want to match the other exponent or exponents to. So one of the exponents. Pick one of the exponents on the 10 and stick with it. That's the one you're going to make all the other 10 to the whatevers into. So you're going to, step 2 is adjust all the exponents to match the chosen one by adding or subtracting. If the exponent is lower than the one you've chosen, you've got to add to it. If it's higher, you've got to subtract from it. If you add 1 to the exponent to make it match up, you've got to move the decimal point 1 place value to the left. If you subtract instead, you move it to the right. This will become a little more apparent when we actually go through an example. Step 3 is to add or subtract, depending on what operation, the first factors after having adjusted them to match the exponents there, and use the common exponent on the times 10 for your answer. Personally, to simplify things here, I like to work with the largest exponent on the tens. If you make the smaller exponent into the larger one, you're less likely to have adjusting at the end there. So if it was up to me, I would say always use the smaller exponent, make it into the larger one, so that every one of these scientific numbers have the same larger exponent on the 10. Makes it much simpler in the end. In fact, that's the only way I'm going to show in the video. For example, here we have 3 times 10 to the 5th and 2.5 times 10 to the 2. The 5 is a larger exponent. So I'm going to make this 2 into the 5. That's step 1. Step 1 was choosing one. I chose the 5. Step 2 is to make this into that exponent. Since I'm not changing this one stays 3 times 10 to the 5. This one, I'm going to make it times 10 to the 5. To make the 2 into the 5, I'm adding 3 to it. If I'm adding 3 place values here, I have to move this decimal point 3 place values. Since I'm making this 3 larger, I need to make this 3 place values smaller. So I'm going to move it over 1, 2, 3, which is going to give me 0.0025. Now, yes, this is no longer in scientific notation because that number is less than 1 in value. But this is just a step in the process of solving. So it's okay to have it like that when you're going through the process of solving. We don't want to forget we are adding these. So now I've got them with like exponents to the 10. So now I can actually add them. I'm going to add the 3 plus the 0.0025. And my answer is going to be times 10 to the 5th power. That common exponent is now going to be part of the answer. So my final answer ends up being 3.0025 times 10 to the 5th. And since we're asked to write in scientific notation, that would be it. Now, if you're asked to express the answer with significant digits, you may need to round that. This would probably round to just plain 3 times 10 to the 5th. Turns out this is not significant enough to make a big difference there. All right, this one here, we're going to do subtraction. Same process. Match the exponents. This is the bigger one. Let's make the 7 into an 8. How do we make the 7 into an 8? We add 1 to it. So it means we're going to move this one place value smaller. So we're going to get 0.45 times 10 to the 8th. And this is 6.5 times 10 to the 8th. When we go to subtract those, 6.5 minus 0.45 is going to give me 6.05. And we're going to have that times 10 to the 8th for our answer. The common exponent stays there at the end. That's our answer on that one. I do not need to adjust the answer. This one, I didn't need to adjust it. It's nice that it worked out that way. Generally, when you convert to the larger exponent, you're not going to need to adjust this number. Sometimes when you're adding, the number's going to get larger, sometimes it's going to be smaller. You might have to, but not always. A lot less likely to happen if you work with a larger exponent. Pause the video, give these two a try. We'll come back and take a look at them. Welcome back. All right, 4.2, this is 21, that's 20. I'm going to make it into the 21, so I'm going to have 4.2 times 10 to the 21 minus, this needs to become 1 larger to make it 21, so I'm going to move it over 1. I get 0.19 times 10 to the 21. 4.2 minus 0.19 is going to give me 4.01 times 10 to the 21. And that's my final answer there. I don't need to adjust the front at all. Here, the larger exponent happens to be on this side now, so I want to make this into a 52, which means I'm going to move this 2 place values over, which makes this 0.038 times 10 to the 52 plus 2.1 times 10 to the 52. 2.1 and 0.0318 for that. 0.038 is going to give me 2.138 times 10 to the 52. Again, the common exponent becomes the exponent for the answer. I don't need to adjust this. This number's between 1 and 10, so we're good. See you in class.